In this video, I will discuss Pearson product moment of correlation R. The Pearson product of moment correlation R is the index of relationship between two variables. These two variables are your independent variable and the dependent variable. The independent variable can be represented by x, while the dependent variable can also be represented by y. The value of r is positive 1, 0, negative 1. If the value of r is positive 1 or negative 1, meaning to say there is a perfect correlation between x and y. However, if the value of r is equal to 0, then x and y are independent to each other. Let us consider the x and y coordinates in the following graphs. So as we can see on this first graph, the trend of the line is going upward, meaning to say the value of r is positive. If so, this indicates that as the value of x increases, the value of y also increases. Likewise, if the value of x decreases, the value of y also decreases. The x and y are being positively correlated. In other words, the dependent and the independent variable are directly proportional to each other. Next. So on this graph, the trend of the line is going downward, meaning to say the value of r is negative. This indicates that as the value of x increases, the corresponding value of y decreases. X and y are being negatively correlated. In other words, x and y are inversely proportional to each other. Then we also have, if the trend of the line graph cannot be established or it is either upward or downward, the value of r is 0. It indicates that there is no correlation between the x and y variables. So why do we use r? We use r because we want to analyze if a relationship exists between two variables. If there is a relationship that exists between the x and y, then we can determine the extent that x influences y by means of the coefficient of determination, which is equal to the square of r multiplied by 100%. For example, if your r is equal to 0.75, then that is 0.75 squared times 100%, which is equal to 56.25%. So that is the percentage that the independent variable or your x influences your dependent variable y. How do we use r? We use the formula r is equal to n times the summation of x times y minus the summation of x times the summation of y all over the square root of the quantity n times the summation of x squared minus the quantity the summation of x squared times the quantity n times the summation of y squared minus the quantity the summation of y squared, where n is the sample size, summation of x, y is the sum of the product of x and y. The summation of x is the sum of x. Summation of x squared is the sum of squares of x. Then, the summation of y is the sum of y, and the summation of y squared is the sum of squares of y. For example, below are the midterm examination results, which will be your independent variable or the x variable, and the midterm grades, that is your dependent variable or that is your y variable, of 10 BSMT students under biostatistics subjects. Test if there is a relationship between the midterm grade and the midterm examination. Use 0.05 level of significance. So we have here the following data. We have the x and y. Solving now by stepwise method, first is to identify the problem. Is there a significant relationship between the midterm examination results and the midterm grades of 10 BSMT students under biostatistics? Then, formulate your hypothesis. For the null hypothesis, there is no significant relationship between the midterm examination results and the midterm grades of 10 BSMT students under biostatistics. Then for the alternative hypothesis, there is a significant relationship between the midterm examination results and the midterm grades of 10 BSMT students under biostatistics. So this is a non-directional test, or this is a two-tailed test. Next is the level of significance. So alpha, that is 0.05. Then for the degrees of freedom, that is n minus 2, where n is the sample size, so that is 10 minus 2, which is equal to 8. And for the R tabular value, let us use the R table. So, let us find for the level of significance for a two-tailed test at 0.05. Then, on the leftmost column, find for the degree of freedom, which is 8. Then, get the intersection of the two, so that is 0.632. So, the R tabular value is equal to 0.632. Then, solving now, we'll be using Pearson product moment of correlation R. So, we have here the data a while back. So, on the first column, we have the x variable, which is the midterm exam. Then, the second column, we have the y variable or the midterm grades. On the third column, that is the square of the x variable. On the fourth column, that is the square of the y variable. And the last column is the product of x and y. So first, let us get the square of the x variable or the midterm exams. So that is 75 squared, which is equal to 5,625. 70 squared, which is equal to 4,900. 65 squared, that is 4,225, and so on. Next will be the square of the y variable. So that is 80 squared, which is 6,400. 75 squared, which is 5,625. 65 squared, which is equal to 4,225, and so on. And for the last column, that is the product of x and y. So that is 75 times 80, which is equal to 6,000. 70 times 75, that is 5,250. 65 times 65 is equal to 4,225, and so on. Next step is to find for the summation of x as well as the x bar summation of y, and y bar summation of x squared, summation of y squared, and the summation of x times y. First, let us find for the summation of x. The summation of x is equal to 775. So that is 75 plus 70 plus 65 plus 90 plus 85 plus 85 plus 80 plus 70 plus 65 plus 90. Just add all the data under the x variable, and that is equal to 775. Then we have n is equal to 10, getting now the mean of x, that is 775 divided by 10, which is equal to 77.5. Next is the summation of y. So getting now the sum of all the data under y variable, that is equal to 815. Then 815 divided by 10, that is equal to 81.5. That is your mean under y variable. Next is the summation of x squared. Summation of x squared is equal to 60,925. Next is the summation of y squared, or the sum of all the data under y squared, which is equal to 67,325. And the last one is the summation of the product of x and y. That is equal to 64,000. So we already have the following values. We have n is equal to 10. Summation of xy is equal to 64,000. Summation of x is equal to 775. Summation of x squared is equal to 60,925. Summation of y is equal to 815. And the summation of y squared is equal to 67,325. Then substitute these values into the formula. So that is now r is equal to 10 times 64,000 minus 775 times 815 all over the square root of the quantity 10 times 60,925 minus 775 squared times the quantity 10 times 67,325 minus 815 squared. So simplifying it further, that is now equal to 8,375 all over the square root of the quantity 609,250 minus 600,625 times the quantity 673,250 minus 664,225. Then simplify. That is now equal to 8,375 all over the square root of 8,625 times 9,025, which is equal to 8,375 all over the square root of 77,000. Oh, sorry, that is 77,840,625. Then that is now 8,375 divided by 8,822.73, which is equal to 0.949. So the R computed value is equal to 0.949. Then, for the decision rule, if the computed R value is greater than the R tabular value, this confirm HO. So our R tabular value a while back is equal to 0.632. And for the R computed value, that is 0.949. So the R tabular value is less than the R computed value. Therefore, accept the alternative hypothesis and reject the null hypothesis. So for our conclusion or implication, since the computed value of R is 0.949, which is greater than the tabular value of 0.632 at 0.05 level of significance with 8 degrees of freedom, the null hypothesis is rejected. This means that there is a significant relationship between the midterm examination results and the midterm grades. It implies that the higher the midterm examination, the higher also are the midterm grades. So that is the Pearson product moment coefficient of correlation. Thank you for watching, and I hope you have learned something.